Hello, welcome to this new session on descriptive statistics. In the last session, we were talking about the visualization of the data. So now we will discuss that what are different descriptive statistical techniques which are applicable to summarize the data. Before we start detailed discussion about descriptive statistics, so let me tell you what exactly we are going to cover in descriptive statistics. We will discuss about measures of central tendency, measures of variability, measures of say. Then we will try to understand what exactly mean, median, mode, quartile, percentile and range are and what are their applications. We will also see that how to compute all these, whether it is central tendency measure, variability or say. Then we will try to understand what exactly is the application of skewness, kurtosis and box and whisker plot. If we talk about central tendency measure, so for ungrouped data, we will be discussing about mode, median, mean, percentile, quartile. These are common measure of location. So if we talk about mode, mode is nothing but most frequently occurring value in a data set. As we have already seen the application of the level of data measurement, so we will see that which particular type of level of measurement will be applicable. So now when we talk about this category, so you must remember in our first session when we were talking about level of measurement, so categorical data where data is only at nominal level. So now there is a situation which is applicable. There is a situation where we will be using this nominal data now. Now, it could be bimodal in some of the cases, and we will see that what the bimodal means. Data set could be multimodal also. So let's discuss median. In case of median, in your school level also, you must have studied that if you just arrange the data in some order, then you pick the middle term, right? So if the observations are in odd number, then you can just simply pick the middle term by using this particular formula, that n plus 1 divided by 2. And suppose in case we have even number of observation, then you might get the value in fraction. So if suppose there is a situation that you have to pick middle 2 observation from that ordered data set, you just take arithmetic mean of those 2 observations. So let's discuss what exactly arithmetic mean is. So simply it is known as mean. Most of the time we just use the word mean to describe the arithmetic mean. It is actually one of the average which we calculate for different observation. This is applicable for interval as well as ratio level data. In case of nominal or ordinal, where magnitude wise to understand the data is very difficult, or in some of the cases it is impossible to see what exactly the magnitude wise the difference. So then we are not able to use arithmetic mean in that situation. So once data is quantitative and it is at least at interval level of measurement, so we can apply all arithmetic operation and we can compute the arithmetic mean by just summing all the value in the data set and dividing the sum by number of values in data set. Now let's assume one situation. For example, the number of US cars in service by top car rental company in a recent year according to auto rental news follow. So suppose we have different car rental companies, for example this enterprise, who are having around 6,43,000 car on rent, and similarly we have other companies. So now if somebody asks you to calculate mode, median, mean, so for mode we need to just see that is there any observation which is occurring most frequently, and for median we have to arrange this data set in some order and then pick the middle one. Then for arithmetic mean we have to sum up the observation and divided it by number of observation. So let's see. In this data set you must have observed that this 9,000 was written twice. This is the only observation which was occurring most of the time. So that is nothing but is your mode. In case of median, we saw that 13 different companies are there. So n is equal to 13, and simply by using this formula 13 plus 1 divided by 2, the 7th position. So in that particular order, when we arrange the data in some order, so that 7th position, whichever value is there, that is nothing but your median. And similarly, we can go for the calculation of mean, just summing up all the observation and divided by the number of observation, nothing is your median. When we talk about percentile, it is actually a measure of central tendency that divide a group of data into 100 parts. At least n% of the data lie at or below the nth percentile, and at most 100 minus n% of the data lie above the nth percentile. For example, if we have to calculate 90th percentile, what we will be doing? What does it mean? That 90% of the data are equal or less than it, and a 10% of the data lie above. So if suppose we have to calculate, so just order the data as we did in case of median. Then suppose if I is a whole number, then use the average of ith and I plus 1th ordered observation. Otherwise, round this I up to the next highest whole number and you will get the value. Then we talk about quartile. So like percentile, as it divide data into 100 parts, so quartile divide the data into 4 parts, 4 subgroup. And if we talk about first quartile, so it is the position below which 25% of the data lies. Then quartile 2, the 50% of the data set is below the second quartile. So this is nothing but it is also your median. Quartile third means the 75% of the data set is below the third quartile. For example, we have to calculate quartile 1. So in the same data set which we have assumed here, so for example n is equal to 13, so then how to identify the quartile first? So 30 into means as per definition 25% of the data lies below this particular. So we have to get the 25% of 13. So which comes out to be 3.25. So the fourth ordered observation, the next round figure would be the fourth ordered observation, which is 9,000, is nothing but your quartile 1. Similarly, suppose we have to calculate quartile 3. So just calculate the 75% of this number, and as it came out to be 9.75, so use the 10th order observation and accordingly you will find the value of quartile R. Which measure do I use? Which measure of central tendency is most appropriate? In general, the mean is preferred because it is mathematically follow all kind of properties. The median and quartile are resistant to outlier. For example, we have three data set. In one data set, there is 1 to 3 as an observation, 1 to 6 another set, 1 to 30. If you calculate median in the first case, so median is 2, and if you take the average, so mean is also 2, and in the second set median is 2, mean is 3, and similarly if you go to the third set, median is 2, mean is 11. So in all we have median is equal to 2, but mean is sensitive to the outlier. It depends what is the magnitude of value in the data set, right? So if you have some large value or if you suddenly have some small value, so mean is very sensitive to the extreme value. So in general, if there are outlier, the median is preferred to the mean. When we talk about measure of variability, so this is a tool which describes the spread or the dispersion of a set of data. It provides more meaningful data when used with the measure of central tendency, because when we use central tendency measure, you get one number. So now we assume that number as a representative of that particular data. But you must have seen that all the values are not of that particular size or equal to that number which we have calculated through central tendency measure. Then what about the values which are either less than the central value or more than the central value? Still some information is there which is not captured, alone due to or by this particular central tendency measure. Then how to capture that particular value? So in that case, measure of variability provide us that remaining information in the data set. Now how to calculate? When we talk about this measures of spread or dispersion, the most common techniques are range, interquartile range, mean absolute deviation, variance and standard deviation, and coefficient of variation. Now let's see one by one. Range. We have already discussed in earlier session that range is nothing but the largest and the smallest value difference. Advantage is it is easy to compute, but disadvantage is affected by the extreme value, and this particular information is based on only the two values which are largest and smallest. What about the rest of the information which is not being captured? What about the spread within the data set? So if suppose extreme values are suddenly higher value is there, so suddenly you will find that range is higher, but there is no role of other observation in the data set. So next measure which is a little bit better, so that is interquartile range. So process is how to calculate interquartile range. We need quartile, so it is actually difference of third quartile and first quartile. Like in case of earlier example where we have done some calculation related to those car in service data. So IQR as per that data set, we have already calculated this. So we can find out this interquartile range. Now the deviation, because in interquartile range still now we have entered at least 25% inside the data from both the direction, but still the 50% of the data is not being used for this particular information of spread. So now if we use deviation from the mean, so that means it will capture all the fluctuations from the mean. Every value, how much far it is from the central value, it will calculate that thing. But if we take sum of all the fluctuation, so it would be 0. So then there is a problem how to capture the information. So for that purpose we have used mean absolute deviation. So in mean absolute deviation we have put this mode to make all the values positive, and now we can get the idea about how much fluctuation, on an average fluctuation, is there. If we sum up all the deviation and divide them with the number of deviations, we will get some value which will provide mean absolute deviation. Again, there is a problem with this measure because artificially we are making all the observation positive. So mathematically there may be some problem. To avoid this problem, instead of taking mode of the value, what we did, we just square the deviation and added them, then divide it by the number of observation minus 1. So that will be the calculation of sample variance. But now the thing is, if suppose data is given in meters, data is given in kg, so you will get fluctuation in kg square, meter square. So if you want the fluctuation in the same unit as the data is, then we will take positive square root of this standard deviation and you will get a fluctuation in the same unit. The sample standard deviation was the square root of sample this deviations, and now this standard deviation is actually the square root of sample variance. So in this case we can avoid the problem and we can get result in the same unit as original data. Now suppose take one situation. The effectiveness of district attorney can be measured by several variables including the number of conviction per month, the number of cases handled per month, and the total number of years of conviction per month. A researcher uses a sample of 5 district attorney in a city and determine the number of year of conviction that each attorney won against defendant during the past month, as reported in the first column of the next data set which is available with us. So now we have to calculate what are the value of absolute mean absolute deviation, variance, and standard deviation. So let's see how to calculate. For example, so this data set is given to us. So now what we did, we calculated the arithmetic mean of all these observations under x, and we subtracted all the values from that mean. So first we just took the mode, or even if we do not use this third column, we can just simply square them. So square them and add it and divide it by the number of observation. But if you divide it by the number of observation minus 1, so you will directly get sample variance, and if you take positive square root of this number, you will get standard deviation. So now standard deviation is actually on an average difference of all the values from the central value. In coming sessions, we will also be using this z-score and we will discuss in detail what exactly the z-score means, but as it uses this standard deviation mu and all these central tendency tool as well as dispersion tool, so we are just showing it here that if suppose we have to calculate z-score, which is nothing but the number of standard deviation a value is above or below the mean of a set number, so that can be calculated in this particular way. Now one of the important technique, if suppose we have to compare the standard deviation of two samples, because average is different, so standard deviation, comparison of standard deviation would be of not that relevance which exactly we want to find in that case. Means if suppose we have to measure the variability, volatility of stock portfolio, so we want to first make it or bring both the portfolio at same level. So in this case, when we have to compare something, we generally use coefficient of variation instead of directly using standard deviation. Standard deviation is an absolute measure, whether coefficient of variation is relative measure of dispersion. So in any case, whenever we have to compare two set of data, we should use coefficient of variation. So which is nothing but the ratio of standard deviation and this mu, right? And if you multiply it by 100, you will get result in percentage. Now for example, we have two data set. In one of the data set, average is 29 and another data set, average is 84, and you can see the standard deviation in first set is 4.6 and standard deviation in second set is 10. So if you look at this number, so it appears that because standard deviation here is less as compared to this second set, but if you look at the average value, on an average, what is the magnitude actually in that data set? So if you look at that magnitude, then 4.6 may be higher as compared to this one, because here when on an average value is 84, so maybe 10 would be less as compared to this set. Means volatility in the second set we cannot compare directly on the basis of standard deviation. If you look at the result, calculate CV for them. So CV for the first data set which comes out to be 15.86 and the second data set which comes out to be 11.9. Initially, suppose on the basis of standard deviation if we look at, so we might have given this statement that second set have more volatility, but which is not true, because this volatility also depends that what is the on an average size of the values in data set. So first bring the two system at same level, then you can compare. So for this purpose we use coefficient of variation. So now we can say that this first set have more volatility as compared to the second set or second population. Because these days we use computer, or most of the time in your case you will be using MS Excel for the calculation. So grouped data calculation may not be that much useful, but yes, if suppose some group data is given, so how to calculate even arithmetic mean in this case. So what you need to know, you just have suppose frequency distribution, some class intervals are there and number of observation in each class interval. So just calculate midpoint and multiply the frequency with midpoint and take the sum of all these products. So divide this sum of all the product with the number of observation, you will get arithmetic mean in case of group data. Similarly, if you have to calculate suppose median, so same you have same data suppose, then what you need to do? You need to calculate cumulative frequency. So now how to calculate the median in this case? First of all, we need to know in which particular class interval our median lies. So we know as per the definition, median is the middle value. So in case of where we have 50 observations, so which observation is actually your median? So divide it by 2. So 25th observation is your median. So now see, and this cumulative frequency will provide you that idea that in which particular class that 25th observation is there. So 25th observation is there in this third class. So in our median formula, we have lower limit of the median class, then n by 2 minus cumulative frequency just before the median class and divided by the frequency of median class multiplied by the width of these classes, so which is comes out to 40.9. So this is the median in case of grouped data. So again, in the simplest case, when we talk about single mode data, so we have to just identify that which particular class is having more number of observation, because as per definition most occurring frequency is nothing but the mode. So here 18 is the maximum number and what are lower limit and upper limit of this class. So just add them and divide it by 2, you will get mode of group data. Then variance and standard deviation of group data can also be calculated. For example, in case of this arithmetic mean, we were calculating midpoint. So similar process is there. You just calculate midpoint of each class, multiply them by frequency and get the value of this product and take the sum of this. Now, because we will also be calculating other thing here, take the square from deviations of each value from the mean. Take the square of that and multiply that square with the frequency. So you will get this numerator part. So and total number of observation are 50. So you will get directly the value of variance, and if you take square root of this, so you can get standard deviation. Now we have very important part of this lecture, which is known as measures of shapes. So we have particularly to discuss here skewness, kurtosis, box and whisker plot. So if we talk about skewness, so skewness is nothing but the absence of symmetry. Then extreme value in one side of distribution. We will see from the graph that how does it look like. Then kurtosis, in which we see what kind of peakedness is there. So as per that we will define. Then we have box and whisker plot. So these are also the graphical display of the distribution, and it also help us to determine that how much skewness is there in the data, or it can also be used to find out outlier in the data. So now when we talk about skewness, what is symmetric data actually? If we calculate the arithmetic mean or the central value, if approximately 50% observations are below the central value and around 50% observations are above the central value, so you will get this type of distribution, this type of graph, which is known as symmetric. But suppose if that is not the case, if there is a disturbance, so now in this case you can see that most of the observations are shifted toward right side. Now right side magnitude wise these are large values. So that means if you talk about, so simply if we just discuss the skewness or the symmetry of the data, so symmetry is disturbed from this left side, right? So most of the observations are more than average value. So this is known as, if this tail is toward left side, you can simply remember it as a negatively skewed. If the tail is toward right side, you can name it as positively skewed. So what does it mean if it is positively skewed? Because most of the observations are below the mean value. Then it comes to kurtosis, which is defined on the basis of peakedness of the data. So if we talk about leptokurtic, so it is very high peak and very thin kind of curve. So now very high peak, what does it mean? If you consider the average value here at the center, so most of the observations are near to the central value. Most of the observations are near to this central value. Here when we talk about this mesokurtic, which is considered actually the normal thing, so little lower. Now what is happening? Standard deviation of data is increasing. Standard deviation of the data is increasing, or you can say the values are going far from the average. So in case of platykurtic, it is again the maximum standard deviation in this case. Now if the kurtosis value is around 3, so we consider it as a normal. So more than 3 it is leptokurtic and less than 3 it is platykurtic. Similarly, if we talk about the skewness, so if skewness value, we will be calculating it in Excel when you will be coming for the live session. So you will see that how to calculate all these things. So right now, just if the skewness value is 0, we will have a symmetric curve. If it is more than 1, so positively skewed, and if it is less than 0, it is negatively skewed. So less than 0 or more than 0 are the values which we need to see. Now it comes the box and whisker plot. When we talk about box and whisker plot, we need to have these 5 values where we calculate median, first quartile, third quartile, and we need to have this minimum value in the data set and a maximum value of the data set. We have earlier seen that how to calculate interquartile range, so which is a difference of third quartile and first quartile. So you just take these two ranges, subtract 1.5 time of interquartile range from the first quartile and 1.5 time of interquartile range from, and add this 1.5 time interquartile range in a third quartile. Now the same ranges you can calculate with 3 time interquartile range. So now see what we will be doing. So if you calculate this part, add this thing 1.5 time of interquartile range, so you will have some whisker this side and this side. If exactly this Q2 is lying at the center, and you will find that there is almost same kind of whiskers are there, same size of boxes are there lying exactly center, you can consider this as a symmetric distribution. And if the data is going out of even 1.5 time of interquartile range, if we add in Q3, if it is still outside this range, so we might consider that data is having some problem, data is having some outliers. Now if some value which is even outside the range of 3 time interquartile range which we add in Q3, so definitely there is some outlier which we need to study separately, or we can censor the data in that case. Now if we compare it with, or parallelly if we see the same thing in case of skewness, so suppose if this box, the difference between Q1 and Q2 is higher than the Q2 and Q3, so you can see this is the negatively skewed data. So it gives us the idea of skewness also. Similarly, we can identify if the Q2 and Q3 difference is more than Q1 and Q2, data is positively skewed. So this was about descriptive statistical technique. So there were some measures of central tendency, measures of variability, measures of shape, which we discussed in this particular session. So I hope you enjoyed the session. Thank you.